All right, so can you guys see my screen now?
Yes, sir.
Okay, great. So may I request again everybody to please open their camera if it's available and if it's okay to you. Okay, thank you, Mr. Pardo. What about the others? Don't be shy. All right, great. So there's now two. So that we can see, how handsome or how beautiful you are. All right. So I think that's it to those who are willing to open their cameras. Anyway, so for today's meeting is just a super short discussion, especially if you already know these topics, union, intersection, and then complement, then actually you can already leave this meeting. Okay. So that is all. That's only if you already have an idea about union, intersection, and then complement. But if you don't have any idea yet, like maybe this is your maybe first time hearing about them, and you don't know how to solve them, then please stay until the end. Okay. All right. So let's start by asking anyone who has a question or clarification so far regarding the our discussion last meeting, probably with the quizzes. And if none, just give me thumbs up just to let me know that everything is okay, everything is all right. You were able to follow everything. All right, so great. So most of you were able to get it maybe. All right. Anyway, so let us start now with the set operation. So let's talk about set operations and then Venn diagram. So what are the differences? So all of them are set operations. And here are the different types of Venn diagrams. Okay. So we have set A right here, wherein we have two sets actually, set A and set B. So set A right here is only talking about the green color, okay, the one that is shaded, okay. And then the other one is set B, but since we're talking about set A only, so just shade the set A. And then A, and then like a single apostrophe right here is like the complement. So once you saw this one means the complement, okay, or the opposite, okay, of this set right here. So the opposite of this set A right here is, of course, everything except the A itself. Okay, so that is why everything is shaded. The universal set, this U right here, this entire triangle, except letter A itself, or the set A itself. Okay, so this one is the uh, A complement, okay, or the complement of A. So are we clear so far regarding with this one? So it's everything except the set. So clear, or anyone who's confused maybe, or who didn't get this one? Are you guys okay? Did you guys eat your lunch or okay? So anyway, so I hope you guys were able to get this one. And then the next set right here is A and B are disjoint sets. So meaning it's very straightforward. So they are disjoint. They are not joined together. So that's why it's called disjoint. Okay, so or in other words, they don't have common elements. Okay, so that is why they are separated with each other. And in here, we have another set, which is B is a proper subset of A. Okay, so you guys already know what is the symbol of a subset. So it's this one. So it says here that B is inside of our set B. So meaning all of our elements of, in set B can be found on set A also. Okay, so that's the meaning of B is a proper subset of set A. So next one here is the intersection or intersect. So both A and B. So A intersect B, or A, this is a symbol of intersect B. Okay, so meaning we are only getting their common elements. Okay, so this is where we put their commonalities. And then for the last set right here, so either A or B, or we read this one A union B, or A and then this symbol by union, which is U and then B. Okay, so meaning we're just trying to get all of the elements of A and B. Okay, or the distinct elements of A and B. So are we clear so far with this Venn diagrams? So if ever you have a question, so just let me know, okay? All right, so let's start with the union set. So union of sets examples. So example number one, we have set A right here and then set B. So set A contains 1, 4, 6, 8, and then set B is 0, 2, 4, 8, 9. And then U is the digits. So when we see the digits, meaning it's everything, okay, from 0 to 9. And then draw a Venn diagram for A union B. So here is actually the step-by-step video on how to answer this one. Though here is the solution. Okay, so A union B is equal to set of these elements 1, 2, 4, 6, 8, 9, 0. So again, if it's union, all we need to do is just get everything on that set A and set B. So all we did is just get all of their elements and then combine them together in one set. Okay, so we have 1, 2, 4, 6, 8, 9, 0. So 1, 2, 4, 4, 8, 6, 8, 9, and then 0. So in here, I just arrange them from least to largest. So that is why this one is quite confusing. Anyway, so you can start with A first, like 1, 4, 6, 8, and then followed by, 1, 6 first, and then 0, 2, 9, and then they combine, or their commonalities, which is 4 and then 8. Okay, so just do take note that in here, common elements, so there's only one that I will retain. So if there's 3 eights or 4 eights, so just remove those duplicates and then just retain one. So the same with 4. So we have 2 4, but we only need one. Okay, so yeah, this is the complete answer of A union B. And then the others can be found on the universal set itself, okay, which is 3, 5, and then 7. So are we clear so far regarding with this one?
Yes, sir.
Question? Okay, so I guess none. So let's now proceed to example number 2. So we have this set A and then set B. So we have these elements for set A and then elements for set B. And then the U is the digits from 1 to 15. Okay, and then the same, draw a Venn diagram for A union B. So all we need to do is combine all of their elements. Okay, and at the same time, after combining them, so we put here the distinct elements of set A, and then we put here the distinct elements of set B, and then we put here their common elements, which is 3 and then 5. So as you guys can see right here, 3 and 5 is repeated from both sides. So we have 3 right here, and we also have 3 right here. So we only need 1, so we can put them between this two sets A and B. So if it's on A only, then meaning it's a distinct element of set A. So we can only find that one on set A. So the same with set B. But if it's between them, in the middle, that only means that this set A, has also this elements on set B. Okay, so both of them contains 3 and 5. Okay, so 3 and 5, and then the rest they are now unique. okay, for this thing. And then, for the remaining numbers that is not included on the set A and set B, so just put it right here, which is 4, 7, 10, 11, 12, 14. So are we clear so far? So in here, arrangement doesn't matter. So you can have a random numbers right here. So arrangement doesn't matter. So in here, I've just made this one from least to largest, so that it's easier to check everything. Like 1 is here, 2 is here, and so on and so forth. Okay. All right. So let's now proceed to intersection of sets. So intersection is just this one only. So you could say that this one is a lot easier to solve or easier to identify rather than having a union. Okay, since we need to do in here is combine everything. But in here, all we need to do is just check their commonalities. Set A has 1, 4, 6, 8, and then set B has 0, 2, 4, 8, 9. And then U is the digits, meaning it's ranging from 0 to 9. So draw a Venn diagram for A intersection B. So here is the solution for this one. But before that, so let's check first. So what are their commonalities? Anyone who would like to answer? What are their common elements? Are
8,
or is?
4.
Okay, 8 and 4. Okay, so I think that's it only. And then the others are now unique. So that is why, oops, ito ba yun? Solution number 2. My bad. That's for the solution number 1. I think I'm lost. Okay, my bad. So I named this one number 1 again since I think it's a new topic. Anyway, so I got confused with this one. So this is another example number 1. Okay, but this one now is for intersection of sets. So yeah, the answer for this one is 4 and 8. Okay, so yeah, that's already it. And then here is the Venn diagram of this example number 1. All right, so let's proceed now to example number 2. So we now have here a universal set of 1 to 15, and then these are the sets, the elements, okay, of individual sets. So draw a Venn diagram for A intersection B. So first, what is their common elements? Is or are? So we may have one or more.
3. 5.
3, 5. What else? Right, so I think that's
That's all.
so. We only have 2, which is 3, and then 5. So here is now the solution. Okay, and then here is the distinct elements of set A and then distinct elements of set B. And then the other elements that is not on set A and set B is on our universal set itself, okay, which is 4, 7, 10, 11, 12, and then 14. All right. So yeah, so you guys can see super easy to understand for union and intersection. Let's now proceed to complement. So all you need to do is get the opposite of that let's say set. Okay. So set A is equal to 0, 1, 4, 5, 6, 7, 8, and then U is equal to the digits, meaning it's ranging from 0 to 9. So draw a Venn diagram for A complement. So all we need to do is get the elements that is not on the set A. So here is a solution. So we have 0, we have 1, but we don't have 2. So we put that one as a complement of set A. And then we don't have 3, so we put that one also. We have 4, we have 5, 6, 7, 8, but we don't have 9. So we also put that one on the complement of set A. Okay. And do I have a Venn diagram? So we don't have a Venn diagram for this one. But if you guys are going to draw this one on a Venn diagram, so draw the universal set first, which is represented by rectangle, and then circle is the set A itself. So in here we have, sulat ko na lang, it's easier to write, 0, 1, 4, 5, 6, 7, 8, and then 9. Okay. And then for the A complement, okay, is equal to our universal set actually, since this is set A. Set A. And universal is equal to A complement also, which is 2, 3, and 9. All right.
There's a set A po, may 9 nakalagay.
Pardon?
May nalagay ka po na 9 sa set A.
Ah, thank you for that. So it's 0, 1, 4, 5, 6, 7, 8 only. Very good, Mr. Brexter. Okay, so thank you. Are you guys able to get this one? The complement of this set.
Yes, sir.
Okay, great. And let's have one more example. Okay, so we have set A right here, which has an element of 3, 4, 5, 7, 8, and then universal set, which ranges from 3 to 15. So draw a Venn diagram for E complement. So it's the same. All we need to do is get everything that is not on the set A itself. Okay, so we have 3, we have 4. Okay, so we will not start with 0, 1, and then 2, since the universal set itself will start from 3. Okay, so please do take note on this one also. So it doesn't always start with 0, doesn't always start with 1. Okay, sometimes it does start with 3, and then it could end also with, with 14, 13. So that depends on the given, numbers for the universal set. So in here we have 3, 4, and then 5, but we don't have 6. So we have to list that one on our A complement. And we have 7 and then 8, but we don't have 9 up to 15. So just list that one on our A complement. Okay. And if you guys are going to draw the Venn diagram of this one, so all we need to do is list all of the given elements of set A, which is 3, 4, 5, 7, and then 8. And for the A complement, we do have here 6, 9, 10, 11, 12, and so on and so forth up to 15. Okay. So are we clear for this example number 2? Okay, so if you have questions, so just let me know. So let's now proceed with the Boolean set operations. So in here we have the universal set or universe as our, equal to 1 to 10. And we have here a set A, which is 2, 4, 6, 8, 10, and then B is equal to 6, 7, 8, 9, 10. So find A intersection B complement. So in here, this one will take you a little bit longer, but this one is also super easy. So all you need to do is list all the elements of set A and then find the B complement. So the elements of B is already here. So all we need to do is find the element of that B complement, which is 1, 2, 3, 4, 5, because these are the elements that we cannot find on the set B itself. Okay, that we can find on the universal set. So for the A union B, so we are now going to get this one and this one. So you can simply remove this one first and then put them side by side. So we can get their common elements. So their common elements are 2 and 4. Okay, and in Venn diagram, so we have two circles now. Oops. Anyway, so let's just say that this is your set A and this is your set B. Set A is 2, 4, 6, 8, and then 10. And then set B is 6, 7, 8, 9, and then 10. Okay, then after that, you can check them side by side. What are their commonalities maybe? So they're common with 8 and 10 and 6. 6, 8, 10. Okay, and then you can now put it right here. All right, and then for the B complement, so all we need to do is get everything. So I think this one is not enough. So let me just expand this one. So we have here B complement, which is equal to 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, yeah. Okay, and then for the universal set, so everything that we cannot find on this set A and set B. So we have here, okay, we don't have 1, we have 2, we don't have 3, 4, 5, we don't have also 5, 6, 7, 8, 9, 10. So I have also missed this one, so I should remove those 6 and 10. Yeah, that's it. So here is the complete Venn diagram of this one. Okay, and then for the A intersection B complement is 2 and 4. May 10 po sa A, sir. All right. Okay. And here, so all you need to do is just write this one, A union B complement is equal to 2 and then 4. Okay, or you can make another Venn diagram for this one, though it's quite weird now since we'll have a different arrangement, like we now have 2 and 4 in the middle, and then we don't have this B right now. We now only have this B complement and then this A or set A. Okay, so with that, if you guys are going to do that one, then it would be something like this. So we have the set A itself, and then the set B, I mean B complement. Set A, and then B complement. So B complement is 1, 2, 3, 4, 5. So 1, 2, 3, 4, and then 5. And then A itself is 2, 4, 6, 8, and then 10. And then check the commonalities. So we have 2 and 4 in common. So simply remove them and put them on the middle. So with that, we now have this A intersection B complement. Okay, and the universal set is equal to, so 1, 2, 3, 4, 5, 6. We don't have 7, we have 8, and we don't have 9. So yeah, so 7 and 9 for the universe. So are we clear so far regarding with this example number 1? So are we good or no? Anyone who has a question or clarification, maybe? All right, so it seems that there is no question. Anyway, let's now proceed to the summary. Okay, so a Venn diagram is a visual diagram that shows the relationship of sets with one another. And then the set of all elements being considered is called the universal set, or it's represented by big letter UN. Yeah, it's represented by a rectangle. Okay, so the complement of A is, of course, A complement. And then the set A and B are disjoint because they do not share any common elements. And B is a proper subset of A. So this means that B is a subset of A, but B is not equal to A. So meaning this A has more elements maybe than our B. It's just that the elements of B can be found on the set A itself. Okay, and the intersection of A and B is a set of elements in both set A and set B. And then the union of A and B is the set of elements in which are in A, in B, or in both A and B. And lastly, intersection and unions with the empty set. So just in case that you were asked that we have this let's say set A that contains any elements, and then it's intersected with a null element, so no element. So all you need to do is answer this a null element because they don't have any common elements. Okay, so maybe it's common with with a null or with nothing. Okay. But if we have this A union and null element, okay, or empty set, so it's now equal to A since whatever is one containing, if you're going to combine it one with nothing or with empty set, so it will remain as it is. Okay. So are we clear with the summary? Okay, anyway, actually, even though we will not meet today, you'll still be able to understand this one since this one is super easy. Okay, and then here is a reference of this module. Okay, it came from online math learning. And yeah, that's already it for the last module.